Okay, in the previous few videos, we learned how to calculate the probability distribution for the binomial distribution. So now we are going to study like other properties of the binomial distribution in this video. So first thing we would like to compute is the mean and the variance. So because we know the probability distribution, even though the formula is quite complicated, but technically we know everything, so like the computer can calculate the mean and the variance if the parameters are given. So I'm going to skip the algebra, but the result is pretty simple. The mean is n times p, the two parameters, right? So it's simple and it's intuitive. Like as the number of trials increases, of course, the number of success would also increase. So the mean is proportional to n, and at the same, on the other hand, if the probability of success increases, then of course the expected number of success would also increase. So um, so the mean is n times p. So simply speaking, if there are 10 questions and the probability of choosing a correct answer is 20%, then it's intuitive to think that the expected points is 2, because like you are on average you are going to choose like one correct answer among 5 questions. So if there are 10 questions, you are going to get on average 2 correct answers. So 2 points. That's how we that's how you can understand this formula. You multiply the number of trials, and p is the success rate of each trial. And meanwhile, the variance is n times p times 1 minus p. P is success probability, 1 minus p is failure probability. And so p times 1 minus p was the variance formula for the binary distribution, right? And what the difference is n. N is multiplied like the mean. N is multiplied in front of the variance. And this is also intuitively understood. So as you could see from this graph, as n increases, the shape of the distribution becomes more flat and like more spread out. So as n increases, the variance would increase. It will be more spread out. And the second part, p times 1 minus p, has the same intuition as the binary distribution. When p is close to 0 or 100%, then there is little uncertainty. But the uncertainty is maximized when the probability is 50%. So that's how you can understand the variance. Anyhow, the results are pretty simple. So if you know the two parameters n, p, then you can calculate the mean and the variance. Pretty straightforward. So here is a question. So like in your homework, you're randomizing all the answers, and then what is the mean and the variance of your grade? You may use the formula, and then it'll be pretty simple. Okay, the parameters are 10. You are trying 10 questions, and in each question you have 20% success rate, success probability. So our parameters are 10 and 0.2. Then the mean is 10 times 0.2, which is 2. So it's either A, C, or E. And the variance is n times p times 1 minus p. The failure probability is 0.8. So you multiply 10 times 2 times 0.8. Then the variance is 1.6. So the answer is A, right? So it's pretty straightforward if you just take the formula and plug in the parameters. Okay, then let's go back to the reservation example again. Now, Let's think about more realistic problem. So now, again, you are the manager of an airline flight. And you know, airlines usually sell more tickets than the number of seats available, right? So we call that overbooking. They accept overbooking, and because they know that some reservations will be canceled. Of course, they have their own like system, and you know, sometimes they are in trouble because of the overbooking, and then they offer some compensation to their passengers who could not take the flight. So to simplify the situation, let's choose more simpler numbers here. Suppose that there is an airplane that has only 20 seats. So for simplicity, I chose a small number. So there are 20 seats in that plane, but the airline company accepted 22 reservations, which is like two more reservations than the capacity. So could be in trouble. The airline could be in trouble, but assume that the probability of cancellation is 10%. And as usual, I'm going to assume that the cancellations are independent. So in this case, the airline company, to maximize the profit, has to understand the distribution of cancellations. So that they have to think about their cost and how much they can accept overbooking and what's the expected number of like passengers who do not come to take the flight. So to do that, we define y, the random variable y, as the number of reservations that are not canceled. So they are the passengers who actually with the ticket and want to on board, right? So, and in this case, y is we know y is the binomial distribution. Then first thing we need to do is to find the parameters for this random variable. Like if you find the parameters, then you know everything. So like guess what is the parameters in this case. It's pretty simple, but it's tricky. There is a trap hidden in this question. The answer is 22 and 0.9. D is the answer. Let me explain why this is the parameter. First, remember we defined y as the number of non-cancelled reservations, which is different from our earlier examples because in the earlier examples we proceed with the number of cancellations. We focused on the number of cancellations rather than non-cancellations. So now we are counting different sides. So earlier we counted from this way, but now we are counting from the other side. So that means like when we count the number of cancellations, then cancellation is success, right? But now we are counting the reservations that are not canceled. Then cancellation is now failure. Non-cancellation is success, right? It's tricky, but I want you to distinguish the difference. So what we are counting is the success, and now we are counting those who do not cancel their tickets, because that's actually the passengers who come to the airport, right? And then the problem is our parameter was defined as the probability of success, but the success is now defined as non-cancelled reservations. So the parameter is the probability of non-cancellation, which is 90%. So, you know, right? So it's tricky. So we are looking at the other side of the cancellation. Therefore, the parameter must change according to the definition of the success, right? So as a result, P must be 90% because that's the probability of what we are counting, the passengers coming to the airport. On the other hand, N is another parameter, the other parameter, and N is in our assumptions, N is the number of trials. But an easier way to find this parameter is the maximum number of Y is another way to find this parameter. In this case, there are 22 reservations. So, and we are counting the number of non-canceled reservations, right? The passengers holding the tickets. So at the maximum, N could be 22 because if no one cancels the reservations, then all 22 reservations are not canceled. They are coming to the airport to take the flight. So in that sense, the parameter should be 22. You are doing 22 trials, or you can think it this way. One reservation is one binary experiment. You are checking if the reservation is canceled or not. So, and there are 22 reservations. So the reason why you may be confused, you may be confused because I said there are 20 seats, but it's nothing. 20 seats, it's just kind of like unnecessary information, redundant here. It does not affect the number of cancellations, right? Okay, so then now the next topic I'd like to show you is how can we calculate the probability greater than something or smaller than something. In the previous video, I showed you how to calculate the probability y equals to something. But what about inequality case? Like in this case, the actual problem arises if the number of non-cancelled reservations is greater than the number of seats, right? There are only 20 seats available, but if like there more than 20 tickets are sold, then there could be some problems. What's that probability? This is the main probability the airline must be interested in, right? What we can do here is there is no, the conclusion is that there is no simple way to calculate the inequality, the probability defined by an inequality. We have to break the inequality into multiple equalities. Like in this case, probability greater than 20, strictly greater than 20, includes only two cases, 22 or 21. So you have to calculate each case separately. So probability for 22 is calculated this way. 22 choose 22, and then success happens 22 times, and failure happens 0 times. So this is gone. It's gone. And the probability for 21, again, use the formula again. 22 choose 21, and then success happens 21, and failure happens 1 time. And then calculate simple algebra will result in 33%, which is quite high. So I showed you in this question, in this example, what I wanted to tell you is how to find the parameters. You have to be careful when you choose the parameters. Once you choose the parameters, then it's pretty mechanical, straightforward. Just you know how to calculate the mean, how to calculate the variance, how to calculate the probability. Utilize those results, and then you can calculate almost anything for the binomial distribution. A probability defined by an inequality is not a problem. You can just split that and break down into multiple probabilities defined by equalities. Okay, that's all. So I have a few more slides, but I'm going to stop this video here And the next slide, I will continue from here. Thank you for watching.